Hello. In the last video we talked about angles and doing geometry with angles. So today we're going to go a little bit more into detail on it. So saw yesterday our drawings can get a little busy, right? We had a big diagram with a lot of numbers all over the place. It got a little messy, but today we're going to learn how to handle those situations a little more gracefully. There are ways to make it clear what we're trying to describe in these situations, and let's look at a pretty extreme situation. We have sort of a point, a lot of different numbers coming off of it. Okay? Got A, B, C, and D. And let's say the question was, what is the angle? What is the measure of the angle at point E? Now that's not a well-phrased question, because if I ask you about the angle at point E, that could mean a lot of things. It could mean this big angle. That's at point E. It could mean any one of these little angles, right? They all meet at point E. It might even mean the angle when we look at this guy and this guy, right? Or this one and this one, right? There's a lot of different ways we can look at and understand the phrase, what is the measure of the angle at point E? So we're going to talk about a more precise way of referring to our angles. If, for example, I was talking about this very big angle, I would refer to it as AED, because that's to say A to E to D. Okay? You simply call out the letters as you arrive at them. So you start at A, you go to E, and you end at D. So we could also draw it this way, D to E to A. And if I called an angle DEA, that would actually be the same angle as AED. The only thing that's the same is the middle letter. As long as that middle letter is the same, then, right, we have AED and DEA. As long as the middle letter is the same, we're talking about the same angle. Oh, and my other letters like A and D and D. It's the same three letters, just the middle letter is the same, in the same spot. Well, I'm not going to labor this anymore. Let's keep moving. So you could see other examples. Look at the other examples. If you see AEB, try to trace your eyes from A to E to B, and you'll see what angle I'm talking about. We're talking about angles. So for this one, we're going to name the angle in blue, right? You see there, it's the first question. It says name the blue angle, not the purple one, but the blue one. Okay. Well, we have these purple lines here, A and D, but our blue angle starts from B, so I'm going to write B, it goes to E, so I'm going to write E, and then it goes to C, so then I'm going to write CE. We're going to write C. So we could have also gone C to E to B, and that would also be correct. So for our first question there, you can put in either of these two things, BEC or CEB. Moving on. We write the letter M in front of an angle to refer to the angle's measure. So in this case here, we're just talking about the angle itself. We're not referring to its measurements. But if I did want to talk about that, I'd put a little M in front, right? So maybe this is like 15 degrees or something. The M means I'm talking about its actual measurement. So there in the picture, in the guided practice, we see MABC equals 90. So that is the measure of ABC. it is a right angle. So we know it's 90. Moving on. Talk about combining angles. And we saw this a little bit in the last video. On each of my corners, remember that I said that the two angles would add up to 90 degrees? Well, that's true for all kinds of angles. Right? This angle plus that angle makes this big angle. And if I'm given the big angle, I can subtract this angle to get this one. Just the same. So I can subtract it, and we're left with this smaller angle. So that's also true. Okay? That's what those two pictures discuss. Now we have a question here. Mix in a little bit of some algebra. Let's say we've got an angle. A, B, C, D. Okay? And we know that this big angle, the measure of angle ADC, is 120 degrees. That's given to us. And the measure of angle ADB is 50 degrees. And the measure of angle BDC equals, we only write 2x. That's the question. The question is, what does x equal? So to find this, we can subtract. We can find the measure of this angle itself. Right? Find the measure of this angle itself by subtracting this part from the whole big angle. And we find that the measure of BDC happens to also equal 70 degrees. Oh, let me be clear. ADB, sorry, in the picture was 70, and so that means BDC would have to be 50. I'm sorry about that. ADB is 70, therefore BDC is equal to 50. Now, the question is not asking what is the measure of BDC. That is not the question. The question is, what is the measure of x? And here we see BDC equals 2x. And if it also equals 50, that means we can say that 2x equals 50 because they're the value for the same angle. So to get x by itself, we divide by 2 on both sides, and we get x equals 25, which is my answer. X equals 25. Okay? Now we've got a special term. Let's say we're given a right angle that can be split into two smaller angles. We've got a right angle, as right as I can make it. We split it into two smaller angles, right? So you have these two smaller angles, and we're going to call them A, B, C, and D. And we can say that angle ADB and angle BDC, as I say, these two smaller parts are complementary. Okay, they are complementary. Well, they are complementary angles. They are complementary angles, but we can also describe them as just being complementary. Complementary is like an adjective, like a description. Complementary angles is more like a noun. It's an idea, right? Like how we have even numbers, and then we have like a number is even, right? You have complementary angles, and an angle is complementary. Moving on. Yeah, so those are complementary angles. A good way to remember it is that complementary angles make a corner. Complementary corner. Okay? Let's start with a C. So looking at this example, A, B, C, D, E. Okay? And the question asks, which of my two angles are complementary? Name the two complementary angles. Note, complementary is spelled with an E, not an I. I made a mistake in the practice. So, to identify two complementary angles, you must first identify a right angle, because that is what defines complementary angles. So our right angle is here. Now, oh, this is an F, by the way. BFD. Now, that being said, BFD is not a complementary angle. But if we can split it into two smaller angles, those two angles would be complementary. So it's not going to include A and it's not going to include E because those lie outside of my angle. But we notice on the inside, it's split into BFC and CFD. So BFC and CFD are the two angles that are complementary. Okay? The second choice and the second from last, the sixth choice. Second and sixth choice. Because they both come together to make a right angle. Now, when two angles come together and form a straight line, like we see in this next picture, we call those supplementary angles. If complementary angles make a corner, then supplementary angles make a straight line. So when the sum of two angles is 180, we call them supplementary angles. So we're going to name two supplementary angles. I'm going to use a black marker for this one. Okay, so we identify my straight line. That's this guy right here. Now my answer will not be AEC. That's just the straight line itself. But if we can break it into two smaller portions, we see we'd have AEB and BEC. Okay? Alternatively, it would also be valid. Now, you would pick these two answers specifically. Do not get them crossed up with what I'm about to show you. Or you can notice these two angles down here, AED and DEC. It's the same thing happening just on the underside. Okay? So those are two pairs of complementary angles. Don't mix these two groups. Do one pair or another pair. You should only be checking off two boxes. Either these two or these two. Okay? Alright. And that's the end of that. So thank you for watching. You have no reason to not get credit on this one now. Here it is, and you all have a great day.